Today we're going to be talking about random number generators. Random number generators are used all over the place in games, right? We need to figure out whether or not, an attack hits you, and maybe there's a 75% chance for that, or whether or not there's, a particular item in a barrel, or any number of things, A lot of AI decisions are based on weighted randoms, for instance. And so random number generators are extremely important. The problem is that they're not actually random, not really. And, I say problem, it's really not actually a problem. And we can get into philosophical debates, right? If I have like a fair die, right? Here's my six-sided die, or D6 for those who are, of the role-playing persuasion. And it has the correct sides. If I roll this, is it random? Well, yeah, for our purposes, it's random. But is it? Arguably it's not. Arguably it's based on exactly how much force and sort of like momentum, how much momentum it has based on its material and how rounded the sides are, how I, the actual roll itself, how I twist my wrists. You could theoretically take, all like the wind resistance or whatever, like the air. You could take all of that into account and have it land exactly the same way every time. So does randomness even exist? I don't know. Probably not. It's probably all just a reaction from, things that we can't possibly predict because our minds are too small to really calculate that kind of stuff. And even like a lot of supercomputers are too small to really calculate it. So truly, a random occurrence or a random event is entirely subjective. And again, this is kind of a philosophical thing. But in games, not really games, but in like computer programming, we have two general concepts. We have true random numbers, and we have pseudo. I'm totally spelling this wrong. I think it's pseudo. And we have pseudo random numbers. These are the two kind of major types of numbers. A true random number, and again, philosophy. True random means that we cannot predict it. Nothing that we have can predict it in any real way. Often it is something that is, almost always, that is something that is done from some external source. So for example, if you go to random.org, this generates true random numbers, for whatever value we can put on true random. So what do I mean by that? Well, in this case, random.org offers true random numbers to anyone on the internet. The randomness comes from atmospheric noise, right? So there's tons of electrical signals all over, all over the atmosphere. There's tons of electrical signals that kind of look like this, and we have no idea what the amplitude or whatever at any given point is. We have no idea what any of this stuff is, and we can't really predict it. So because of that, it's considered true random. So, this is a true random number. We can't really predict it. And this goes into some more details, right, that we could go through, right? It's better for some people, like lotteries and things like that, right? Because pseudo-random number generators are a hell of a lot more predictable. Whereas it is, about as fair as you can get. So I encourage you to kind of look at this stuff. You can actually generate one at any time right here, right? You can just go here and generate a true random number. I've already done so. I hit generate and it was 63. Sweet. That's my true random number, which is useful for, statistical models. And, they have examples here, right? Useful for, driving different things. They say online games. I don't know if any online games actually use it. That'd be interesting. If you work on an online game that uses, random.org or some true random number generator, it would be really interesting to see whether or not you guys actually use it. I don't know anyone who actually does, but I also haven't really asked. I've never used this except to generate a random number. I teach classes, and sometimes in those classes I'll do a lottery of some kind, and I'll use this. And I don't use it because I want a true random number. I use it because it's super convenient to go to this site and hit generate. That's pretty much why. So this is one kind of random number. The other kind of random number is a pseudo-random number. Now, a pseudo-random number is something that is not actually random. The basic idea is if you have any kind of given value, like let's say, I'm going to start really, really simple. I'm going to say that we have an 8-bit number. So, your 8-bit number might look like this. This is an 8-bit number, right? This is a 16-bit number. This is an 8-bit number. There are 8 ones and zeros that make up this particular number. If I were to try and randomize this, what I would do is I would take this number and I'd put it into some kind of like machine, which I'm going to draw as a box for fun. Now, this machine's job is to basically take this random number and mangle the bits such that the output of the random number is something that can't be easily determined, right? That's all that it does. It just mangles the bits, which means it's perfectly predictable. So if I have this number and I randomize it 5 times, it doesn't matter when or how often I do it. If I take the same number, mangle it, however many times I mangle it, I'm going to have the exact same result. So that's why it's not true random. Now, it all depends on how you seed it and all this other stuff. And there's lots of cryptology and or cryptography and all this other stuff. Like, these are really, really hard, difficult problems to solve that you need more sort of true randomness for that kind of stuff because you can't predict it. The problem is that this is a pattern, right? So if you're trying to deal with like encrypting stuff, probably you don't want to have a pattern. Patterns seem bad. So that's, random number generation can be really important in that kind of case, in those cases, statistical models and stuff like that. You can skew some of your statistical models if you have a pattern that it's following. So this leads us to this really interesting field of computer science, which is, are random numbers good? And how do you even determine that? Well, it turns out there's a whole, series. You can just Google it. Here's my results. They're just all over the place. Here's overview of statistical tests. There's a frequency test, right? How often does it reappear? I'm not going to go through all this stuff, right? Various tests, the chi-square test. I don't actually know what this is. Yeah, more frequency stuff. Collision tests, tests on nearby values, serial tests. All these crazy tests. There's one called, what is it? It's like Giant Crush or Big Crush or something like that. I think it's Big Crush. That's a whole suite of tests. Here's another whole suite of tests. There's Die Hard. There's Test U01. There's these guys here. We can actually go to these and see what these tests are. Here are the Die Hard ones. This is what they are. There's various different spacings and things. There's the Test 01, which has all these other tests. And there's different types of ways of generating these random number generators. Here's more. Here's a bunch of stuff. Here's how we can kind of test all these different things. Here's an overview of what the tests actually are. It just goes on and on and on and on and on and on and on, right? And so here's my question. How much do I actually care about this? The answer is, a little, not a lot. Because, this is a quote, or an adaptation of a quote, because I don't remember the exact quote. This is a quote from a friend of mine and a colleague of mine who says, when it comes to random number generation, we are not trying to predict cancer growth cells or simulate the growth of cancer or something like that, like a lot of these researchers are. We're trying to determine if there's a sword in a barrel. So who cares? I don't actually care how super accurate or perfectly random it is. I need it to be basically random, and I need it to run super fast. That's my criteria. Okay, so we're going to focus on pseudo-random numbers because that's what we care about. In games, that's what you're going to use. So a pseudo-random number generator has 2 things. It has a seed, which is some value, and it has a some kind of random function, which is a simple thing that sort of mingles the seed. Then it will set the seed to the new mangled thing, so it overwrites the seed, and then it returns the seed. That's basically what this rand function does. That's all it really does. And so, this stuff probably isn't news to you. You're probably used to kind of, at the top of your program doing some kind of like srand, unsigned int, right? You've probably done this before. Time, null pointer. I think I have the parentheses correct here. And then somewhere in your program, you're doing like rand, percent, whatever your max value is, right? You're probably used to doing this kind of thing. So there's several issues with this. And I'll get into all the like painful stuff of rand in a minute. So all this is doing is it's mangling some big seed and kind of going. So, again, we have some side effects. Side effect number one is it's repeatable. It's a pattern. And by the way, in games, this is often a good thing because we can repeat things over and over and over, and that's what we want. Number two, which I already kind of said, there's some kind of pattern, which if it's easily determined is bad, especially if you're working on something where real money is involved. That's really bad. But it allows people to cheat a little easier. And three, the how do I put this? It's sort of only as strong as the initial seed. If you have a crappy beginning seed, you're going to generally get crappy results. And there's a bunch of other stuff. There's like, I think it's called period, which is like how often it repeats. And what I mean by that is if I generate 10 million random numbers, there could actually be an actual repeat. Like it could repeat the entire pattern over and over and over. It could cycle. And there's a bunch of, there's more, right? But these are the ones that we sort of care about for now. Okay, so let's talk about some of our options. Option number one is rand. That's the easy option. So let's talk about rand. Why I hate rand, right? Why I hate rand. And you should hate rand too. Why I hate rand. And then in red, it gets an angry face. It gets a sad, here, I'll do this. That looks like more of kind of an angry face. Because screw rand. Rand is terrible. The C++ standard committee, the ISO standard committee or whatever, I think they're even trying to deprecate it. It may even be officially deprecated. As a slight aside, there actually is a random library, which I also hate. It's pretty good. It's just more than you want. Like there's a lot of overhead for this random library. And it's kind of unintuitive. Like, honestly, this is what I want. Something like this. Okay, so why do I hate rand? Number one, the seed, and this is just depressing, is global. Why is this bad? Well, the seed being global means it's not thread safe, right? At all, in any way. You can only do random numbers on one thread or you're screwed. Number two, you can't have different random number generators for different purposes. For example, here's a big example. In a procedurally generated world, let's say that I have, a bunch of planets that exist. And these are generated planets. And so the easiest thing to do is to say, okay, this planet has a seed of, 13892 or whatever. And you just save the seed so that you can basically set the random seed, generate the planet with your normal random number generator stuff, with this seed, and it will generate in the exact same sequence. That's why repeatable is good. Because now all I have to do, this entire planet is this, plus a delta of things that I've changed on this planet. That's all that's here. Unfortunately, let's say that I do that, and then as soon as I land on this planet, I make a vase, and it's like super high quality. Now I know that every time I visit this, that if I ever need to make a vase, I can visit this planet and do it. Because remember, it's the same sequence. If this is my sequence, of random numbers, anytime that my seed is 89, my next value will be 32, my next value will be 19, my next will be 4, my next will be 8. Always. That's how pseudo-random number generators work. They're just mangling bits. It's just math. So what you typically do in this case is you have two. You have your procedural content generation random number generator, and you have sort of a gameplay random number generator, which you don't change. This just keeps going. Where this guy is something that you change, that you set whenever you're doing it. So you have multiple random number generators, and you can't do that with this. I mean, you can sort of half-ass it, but you're constantly resetting things. So that's number one. Number two, another reason why I hate it. There's a constant, and by constant I mean it's a macro, called rand max, which is literally set to the value of this. I think it's actually just this, to this 16-bit value. Right? That's not a lot. If we go here, and we go to Programmer Calculator, and we go to hex, and we say 7FFF, you know, what's our value in decimal? It's not a lot. It's actually very, very little. Specifically, it's sort of the max of a signed short. It's the max of a signed 16-bit value. Approximately 32,767. That's your max. It gets worse. Rand is just terrible. It generates poor quality random numbers. I'm going to say 3A, especially the lower 2 bits are very predictable. So already you're screwed if you're generating 0, 1, or 2, or 3. So, in fact, it's so bad that often you end up with rand shift right 2% whatever your max is. Usually, you often end up with this to get even halfway reasonable results. Okay, so what does that mean? Well, that means that we can't use 7 anymore. Now we have to say 1FFF. Oh no. Let's go to hex. Right, because we've now shifted it. We have to shift it by 2. So now our actual practical maximum is 8,191. Raise your hand if you've ever needed to generate a random number that's above 8,191. Right, it's just, so rand is just unusable. In my opinion, it is unusable. Right? We cannot use it. I'll give it one thing, and I'll write it here in blue. Right? So this is the bad. What's the good of rand? There are actually 2 things. 1, all right, it's super easy. Number 2, and by the way, we can still make this work. Number 2, it's actually really fast compared to some of the other options that we have out there. So that's what we got. What are the other options, though? You know, we have a bunch of other options I've mentioned. Option number 1 is, well, there's a bunch. Like, I'm not going to go through all of them. There's tons and tons and tons. I think that the main contenders are Mersenne Twister, which is this guy. And here's some code for it. It's sort of non-trivial. And then there's this guy, which is called XOR Shift. XOR Shift 128 plus, in particular, this guy, is one that I particularly enjoy. Now you'll notice that it stores global state here, but you can wrap this in a class, and that's usually what I do. Here's one thing that I'd like to point out. This is 6 lines of code. 6 lines of code, 7 if you count the state. And it generates generally very, very good random numbers. It is Big Crush, I was right. And you can read all about it here if you just search here in Big Crush, or not Big Crush, if you search for XOR Shift. XOR Shift 128 plus. It's great. It's 7 lines of code, right? It's nothing. It's just this. So who cares? Why would you ever use rand? You have 6 lines of code to do it. Okay, this is getting kind of long, so I'm going to wrap it up with this. I wrote this to test a bunch of stuff, and I'm going to run it. So I sort of test the quality of a random number generator. This is rand, so it's okay. You know, there are some clusters of blue. It's just generating random pixels, by the way. That's all it's doing. The next one is Mersenne Twister. It feels a little more spread out, but I don't see a huge, it's still clusters. I don't see a huge difference. This is XOR Shift, about the same, right? This is a fourth one I just call it Squirrel Rand. That's what the author called it. Made by a guy named Squirrel. If you look up like the GDC Vault, you can find a bunch of his talks where he talks about this in particular. So those are the main ones. I'm gonna remember what all the keys. These are what all the keys do. I have to actually remember what these do. So now we're gonna run a coin test. The coin test is literally 0 or 1. So rand. You know, I'll just do a few of them. Oh, you can actually see it. I'm gonna kind of point this out. Here's where rand starts to fall apart and why it's, you know, what I mentioned, right? Like, you can see it here. Just look at this, right? Here, I'll undo this. Like, you can just see it here. You know, I'll do it again. Like, you can just see these, like, streams of things, right? You can see it repeating. You know, I'll undo this. You can just, like, look at this. These are just big repeats. Right? Whereas, strong one. Let me go back here. So if I go to number 6, this is Mersenne Twister. Much better, right? I'm not seeing any of those patterns anymore. Mersenne Twister is much better. The problem with Mersenne Twister is that it's very, very slow and stores something like 4K of state. Here's XOR Shift. Again, I'm not seeing any patterns. Not really. I'll see little runs here and there, but they don't repeat like they did before. Squirrel has a lot of patterns. Squirrel Rand is very fast and it's very cool, but it breaks down at really small numbers completely, as you can see. But it has other benefits to it as well. This is a triplet test where I'm just doing red, green, or blue. So here's Rand. You know, it's okay. I'm not seeing any. I'm seeing a few patterns, not really. You know, Mersenne Twister looks good. XOR Shift looks good. Squirrel actually looks fine at 3. Okay, so now let's look at some of the performance. You know, what does performance look like? It's this guy. This is my performance tests right here. And, oops, I'll zoom this guy in. Let's see how I want to do this. So I'll pull this guy here. And let's minimize this. All right, so number 1. This first test is what I call the all calls per millisecond. So it's the calls per millisecond. So if I hit this button, not that button, this button, there we go. Yeah, I'm running through release. So I'm running in release mode, so not debug mode. I'm not running through the debugger. And here we go. So what we have is rand. So the first column here, I can't see it. This is the one that I want. Okay, so the first column, which is this guy, is going to be number of calls. Let's do this. I'll pull this guy down here. That's better. Okay, so this is number of seeds that I was able to do and number of random calls, because seeding is a big deal. And so this is how many was I able to do in a single, I think it's per millisecond. What did I say? All calls per millisecond. Yep. So if we go back here, then I was able to seed 243 times in a single millisecond, and I was able to call rand 257 times. Bleach is the Mersenne twister. It's the old version that I use. I could seed 55 times. That's not a lot. And I could call 275. So it was actually faster in the long run, which was interesting. XOR shift, I could seed 235 times and call 271. And Squirrel was 259 and 280. So in terms of pure performance, Squirrel definitely won here. It was able to seed and call faster, which was actually his point. That was what he wanted to do. If I look here, this is just undoable. It's not undoable, but you know what I mean? This is just crazy. And actually, in this instance, it looks like Rand was pretty low on the totem pole here of how many of these I could do. Our friend XOR shift is pretty high up there. So that's great. These are just dummy values when I was debugging that stuff. Okay, so let's look at the next set. The next set, if I open this guy again, let's do W. So this is all n calls. So how long did it take to do some number of calls? I don't remember what I actually chose for the number of calls. So if I go back in here and zoom this guy back in, we can see that rand is the amount of time that it took for a lot of this stuff. So rand actually performed sort of slower in this particular instance. So I ran some number of calls. Again, I don't remember how many. And rand was really slow. I'm actually surprised at how slow it is here. I'm going to run it again. Oh, I can't run it again. I have to click on this guy. Interesting. Yeah, it's actually slower. Okay, I'll go back and erase that. I thought it was faster than this. Whereas these are super fast, right? It took a second and a half. Look how nuts this gets with something like, something like Mersenne twister, right? Look how insane this is. Here, I'll erase all this stuff. Look at this. It took a second and a half to seed however many times I told it to seed. A second and a half. During runtime, Squirrel wins. Mersenne twister is actually really good. XOR shift does pretty good. The seeding, though, man, is just brutal. That's a lot. A second and a half. It also has spikes because it will have to kind of regenerate its 4K of data. Mersenne twister gets some of its speed through just maintaining state. Squirrel, again, is much, much faster, wins that battle. I don't have the profiler attached, so I'm not going to do the profiler tests. And then there's the template test to test some architectural stuff that I was doing. So, that's what we get. My very, very big recommendation is use Mersenne twister, or not Mersenne twister, use XOR shift 128 plus. That is going to be your window to success. So this XOR shift 128 engine, if I go here, if you're curious, the code is really simple. I created this internal seed, which is just an unsigned int 64. It requires basically a 128-bit number because that's why it's XOR shift 128. I've just created some sort of basic getters and overloaded some operator stuff here. Very, very kind of simple stuff to be able to set the seed to whatever I want and treat it as its own sort of object. But really, at the end of the day, I can just seed the number, which seeds it with the current time. I can set the seed to whatever value I want. I can seed it from an integer. Sometimes it's just useful to type in an integer, mostly for debugging. I can get the seed itself, obviously. And then here's the random functions, right? I can call sort of old school rand, which will just cast it to an unsigned int, because that's a lot of times what we want. Or I can just get the raw random itself as an unsigned 64. Literally, this is it. And my real random number generator, my actual game project, has a bunch of different kind of helper functions and stuff. But the actual code, it's just rand 64. This is a copy and paste almost exactly from it. I haven't changed anything except some of the names maybe, but it's basically a copy and paste from the Wikipedia article. And all I'm doing is internally managing, the game state. That's it. That's all I'm doing. So there's nothing crazy here at all. Okay, that's it. I hope that you found this useful, this sort of talk into random number generation and how it works a little bit, and how you can kind of do it yourself. Like, I would just write this function and keep it with every project that you use. It's fast, it's simple, it's pretty straightforward. You know, the Mersenne twister is a reasonable alternative. This is my implementation of it, which was taken from Game Coding Complete, which is a book that I helped work on, although I didn't author this. This was authored by someone at Compulsive Entertainment and was basically used in the book. So I pulled that implementation. So that's what this guy is. Also, again, mostly taken from the Mersenne twister that you'll find like on the internet. But its big issue is, where are you? This guy, rand n. So, you know, it's going to store, whoops, let me go back to where I was. What is this value? 624 times 32, actually times 4, because it's 4 bytes. So it's going to store 2K, 2.5. So it's 2,496 bytes, not including this guy and not including the actual seed itself. So it's going to store 2.5K of state, which is significant for a random number generator. That's a lot. That's one issue. And then the other issue is that if it reaches the state where it has to like reset the seed, you know, if it reaches one of these states where it has to like actually deal with kind of reinitializing that array, then it's a slow turn to do that. Although this overall performs pretty quickly because it's just digging through that array. That's it. Let me know if you have any questions or any of that kind of stuff. You know, again, I'll probably put this link in the comments or in my description for the video, so you guys can check out XOR Shift. That's the one that I recommend. That's the one that I personally use. I don't need a lot of the extra craziness. It's trivial to implement. It's really easy. That's about it. Okay, guys. Thanks for tuning in, and I'll see you next time.